Okay, here's a line follower robot. Important things to be aware of with the line follower. Same as with the mouse robot. The motor needs to be attached correctly. In this case, the wheel is back towards the rear of the robot. The label for the motor is towards the front. If this is flipped around, their robot's going to be popping backwards. It won't be able to read information from the sensors as it drives over the lines. So make sure these motors are on correctly. I always tell the students, make sure the wires from the motors are coming off the back side of your robot. Okay, it's important to catch that. Okay, so this is the line follower. I've touched the corner sensors at the same time once. So I've programmed the robot to go forward until it reaches a black line going all the way across horizontally across its path. It can be kind of hard sometimes to get this to start. Really press hard against that middle sensor in order to get it to recognize that you want to select the program to begin. So you see it went forward one space. Now, if I want to make it turn left after going forward one space, I'm going to hold the left sensor one time, and let's see how this acts. See how it's turned left? What if I want to make it turn left again? Okay, I've selected that once. So it's going to go forward one space, left, and a second left. Okay, great. I'll make it go one more time to the left. We'll come back to where we started. Okay. Excellent. At this point, I can make it turn right. By touching just the right corner once, the light will move one space, showing that you've programmed it to turn right. So now we've got forward, left, left again, left, and then right. See what happens. Okay, that's going to happen sometimes. When it tries to turn right, it may actually do a full U-turn. That's pretty normal. Let's see if that happens again. Okay, you'll notice that happening. It may be that you need to go straight again, or it may be that just in this case the black line is not being registered in the way that you want it to. You could try adjusting sensitivity as well. I'm going to erase that right, and I'm going to make it go straight. By erasing, the light moves back one space, and I can then program a new movement. So I'm going to make it go forward instead of turn right. And here we have it, okay? And erasing is something I do by touching the left and the center at the same time. And if you hold the left and center, you'll see that the light has gone back all the way to step 1, and if you run it, nothing's going to happen. Okay? Okay, here I've programmed the robot, line tracer robot, to go straight one space. Let's see what happens. Okay, it turned. Why did it turn? You might think it's because I programmed it incorrectly, but actually it's because my wires are on here incorrectly. You've got to make sure that it's red on the outside, black on the inside. Red for the plus, black for the negative. Also, students can get motor 1 and motor 2 confused. If you switch motor 1 and motor 2, oftentimes you'll get a spinning motion instead of a forward motion. Or it'll go backward when you think it should go forward. So checking how the motors are attached is a quick and easy fix for a lot of problems that you may encounter with a line follower. If you have a board like this where you've got a lot of intersecting black lines, you can either make it out of electrical tape on a white poster board, or you can draw it. Activities that are good for this are to give a starting and an ending position to a student and have them make the robot go that precise path. Once they've gotten the path figured out, you can add an obstacle. So let's say you wanted it to go straight and to the right to end here. Well, if I put an obstacle here, they've now got to write a different program that comes around this way. The more obstacles you add, the more complicated the plan is for them to complete. If you don't have a path like this, You can also just have students draw it with either a black crayon or maybe a black marker. The width has to be about an inch, no bigger than that, or it won't work. And it needs to be a dark line, very dark black line. Any white in that blackness, if they don't color in completely, it's going to make this not work as well. Okay, with the line follower robot, if you've got extra time and you want students to do something with their robot on their own, you can create a challenge for them. So pick any object, here's a tube shape, and have them carry it on top of their robot. Now when this moves, this is going to fall off. So they need to create some kind of a basket or a chamber for things to be carried. And the more that they can carry, the more successful they are. Now, adding weight to the robot can cause it not to move as well. And that's an important thing to learn by experience. So you can have them build an elaborate cage to hold things. They may even attach some kind of a trailer and put things behind the robot to carry it, or in front. All those are going to maybe affect the performance of the robot, and that's okay. But again, let them use their pieces to build something to hold large, small objects, whatever you choose. A tennis ball would be fine, or a golf ball, or 2 golf balls. That gives them a chance to keep building on the robot after they've finished all the activities that you've assigned them.